Hello everyone. We are excited to share a project that tackles a critical challenge in software development, translating concurrent Java applications to HarmonyOS NEXT using ArkTS. This transition is complicated by the fundamental differences between Java's shared memory model and the ArkTS actor model, creating a significant barrier to seamless migration. Traditional tools like JSpeed are inadequate, lacking support for concurrent programs and being incompatible with ArkTS. This limitation led us to explore the potential of large language models to facilitate this transition. Our solution is the LLM-based Java Concurrent Program to ArkTS Converter. Our journey began with several challenges. The training data for concurrent LLMs lacks information about ArkTS, rendering direct usage ineffective. Fine-tuning these models is hindered by the scarcity of high-quality ArkTS data. Moreover, writing effective prompts for one-step code translation is nearly impossible. To overcome these obstacles, we leveraged the extensive TypeScript code available in LLM training data and broke down the translation process into manageable steps using LangChain, enhances efficiency and accuracy. Java relies on memory sharing through shared memory, while ArkTS uses message passing and lacks native support for shared memory. As a result, the crux of our solution lies in creating memory sharing and synchronization mechanism in ArkTS, achieved through the ThreadBridge library, which supports us to write concurrent programs using an approach similar to Java. In order to implement the ThreadBridge library, we use shared array buffer to implement data sharing. A ThreadBridge library simplifies memory sharing in ArkTS, which lacks built-in support for this feature. We utilize shared array buffer, an API in TypeScript that enables shared memory for parallel computing, while ensuring implicit type declarations for ArkTS. ThreadBridge implements functions for each basic type to convert them into shared array buffer objects, facilitating efficient data sharing. To handle synchronization, we designed sign start and sign end functions to acquire and release logs using ArkTS Atomics class. Simulating Java synchronized mechanism, we implement the thread class and runnable interface similar to Java, allowing for proper thread management through ArkTS Task Pool API. Now, let me introduce overall architecture of Java to ArkTS Converter. The Java to ArkTS conversion process begins with Java code being processed by a Java parser. This is followed by converting the parser code into TS-like code via the TS chain. To simulate shared memory in ArkTS, we utilize the ThreadBridge library, enabling shared memory-like interactions. Concurrent code is then translated using ThreadBridge, processed through the concurrent chain and the synchronization chain. Additionally, we leverage TypeScript and advanced prompt engineering to enhance the conversion process. Finally, the results are merged and errors are checked to ensure accuracy and consistency in the translated output. The Java to ArkTS converter utilizes LangChain to create a chain-of-thought approach for code conversion. We break down the conversion into three main chains. 1. TS chain converts Java code to TypeScript-specific syntax for ArkTS. 2. Concurrent chain translates Java concurrency semantics using ThreadBridge for multi-thread shared memory. 3. Synchronization chain handles synchronization code with the ThreadBridge library. Because using the same set of prompt words may be inefficient and may result in errors, we employ abstract syntax tree analysis to ensure that we select the appropriate sort of chain for each class. ArkTS chain focuses on converting non-concurrent Java code into TypeScript, benefiting from the LLM's familiarity with TypeScript. However, in complex cases, the LLM may lack contextual information. To mitigate this, we prompt the LLM to summarize all Java code into contextual information, which we provide in subsequent prompts. The concurrent chain facilitates memory sharing by enabling the LLM to understand and use the ThreadBridge library. We begin by prompting the LLM to grasp the getValues and setValues functions, assigning specific rules at the start of each prompt. Examples are provided to clarify usage. Next, we get the LLM to understand the getShared function, ensuring all member variables are initialized correctly. Additional subchains help retrieve necessary constructor information. Despite our efforts, the LLM may still misuse these functions, so we enhance the robustness of the ThreadBridge library to tolerate common misuse cases. The LangChain leverages the ThreadBridge API to convert the synchronization components of concurrent programs. The LLM replaces the synchronized keyword with signStart and signEnd, ensuring proper encapsulation of the corresponding code blocks. We also direct the LLM to generate unique identifiers for synchronized blocks, which are then passed to the signStart and signEnd functions, completing the synchronization code conversion. To validate our converter, we created 53 Java concurrency code samples based on classical synchronization patterns, including producer, consumer, and reader-writer, with varying difficulty levels. We use the JRE and the DevEco Studio, the HarmonyOS IDE with ArkTS, to execute and verify the code, ensuring consistent results with stable API version 9. Among the 53 test samples, 66% successfully compiled, with an accuracy rate of 69%. The most common errors were related to the misuse of the ThreadBridge library, where the LLM often misapplied functions or introduced new elements that conflicted with the context. Our runtime error analysis indicated that nearly 2/3 of errors resulted from the LLM's incorrect use of the ThreadBridge library, particularly in complex scenarios. However, for moderately complex programs, our approach reliably ensures accurate conversions. This tool presents a LangChain-based converter for translating concurrent Java programs to ArkTS, the language of HarmonyOS NEXT. Our experiments demonstrate a 66% compilation success rate and a 69% accuracy among the compiled results from 53 test samples. Common challenges include misuse of the ThreadBridge library and the introduction of unnecessary elements by the LLM. Despite these challenges, the converter shows significant promise in automating Java to ArkTS translation, reducing manual effort, and accelerating HarmonyOS NEXT development. Future work will focus on improving accuracy and expanding support for various concurrency patterns. Thank you for your listening.